Assalamu alaikum.
Walaikum salam.
Sorry for the delay.
It's all
Okay.
right.
So did you complete the homeworks that I gave you?
Uh, I got busy with my other homework.
All right. Okay. So I guess practice here then. So H3PO4, calculate the valency of phosphorus here, or the oxidation number of phosphorus here. Okay. H3PO4. Very easy.
Oh, H3. Oh, plus three, plus three, plus 4 times 2, which is eight, -2.
Negative 2. How is that? How is -2?
Um, because hydrogen has +1,
Okay, +1. And how many hydrogens are there?
3,
Okay, next.
1 phosphorus, which is +3.
You have to calculate for the phosphorus. You don't know what is the
Oh,
okay.
that makes so much sense. Hold on. Oh yeah. Okay. Well then, 3. That'll be +5 then.
Yes, +5. Okay.
Okay.
So x
Sorry.
plus x minus 8 will equal to 0. That means if you calculate it, then you will get the value of x to be +5. Okay. Now try this one. K2Cr2O7.
K2. Oh.
K2Cr2O7.
Mm, +6.
Right, +6. So what I tested here was if you would say like +12 or +6. Okay, so you said it correctly because potassium will be +2 and oxygen will be -14. And to balance it, we will have to take, so okay, so this is +2 -14 plus x equals to 0. And then we will get x minus 12 equals to 0. Sorry, that is twice x equals to 12 and x equals to 6. Okay, so there are two chromiums. That is what we have to consider it. Okay, so I hope you will be able to solve these questions. All right, now, okay, try this one, this redox reaction. Now you have understood how to write down the redox reactions. Now it's all about practice. Okay, try this one.
Okay.
First of all, write down the write down the oxidation numbers, then see the change in the oxidation numbers, and based on that, write down the half reaction and half oxidation reaction. I hope you are being able to follow the steps, and if you find any difficulty, please let me know.
Okay. The nitrogen would be at -3. No,
Nitrogen would be, yes, go ahead.
-3. Yeah, -3. Yeah, okay.
In which side? In the left side or in the right side?
Right side.
Yes.
Oh, sorry, +3, +3.
Why would it be +3?
Wait, no. Hydrogen will be plus.
It's not a metal
And
hydride, okay? In case of metal hydrides only, hydrogen gets an oxidation number of -1. Other than that, hydrogen gets an oxidation number of +1. Okay. So as it is not a metal hydride, okay, it will in this compound, hydrogen will have an oxidation number of +1. Okay. It's not a metal hydride. Okay.
okay, then
Not
if that's so, then nitrogen would be a half reduction, while hydrogen would be a half oxidation.
okay. And have you written down the equations?
I think so. Yeah.
Okay, let me check. So this is 0, this is 0. Okay. So now -3 +1. Okay. Okay, so this would be okay, half reduction, and in case of hydrogen, it will be half oxidation, right?
Yes.
All right, half oxidation. Now the equations would be something like this. So N2, which we can write like 2N minus how many electrons? Just here, it's around 6, right? 6, okay. 6E minus, then we get 2N, 3 minus, okay. And then 6H minus 6E minus, it becomes 6H plus. Did you write these two equations?
Yes.
Okay, excellent. Excellent. All right. So you have understood how to balance the oxidation and reduction reactions as well. Okay, so that's good. All right. Okay, now try this one.
Okay. Decomposition reaction.
Decomposition. Decomposition means a particular compound would decompose into two specific compounds. Okay. So for instance, here it was PCl5, and if you like add heat or like do electrolysis or some sort of different operation, and it has divided into chlorine and phosphorus trichloride. Okay. So phosphorus pentachloride has divided into two parts. In one part, there are only two chlorine atoms which made a chlorine molecule. And then you have one phosphorus and three chlorine to make a phosphorus trichloride molecule. Okay. All right. This is how decomposition reaction works. I hope you are enjoying redox reactions now. I know it took a
It's
little time
okay.
to understand, but if you understand, then it becomes really easy and it becomes real fun as well. It's a little difficult to understand. A little difficult.
The phosphorus is the half reduction, while the chlorine would be the half oxidation.
Okay. So this
Oh wait, no, wrong way.
plus.
Wait, no.
All right.
Hello?
Yes, I can hear you.
Oh, okay, sorry. Sorry. Hi.
So I mean, did you want to revise something, or like are you saying phosphorus is half reduction?
Phosphorus is the half oxidation.
Okay, half oxidation. Okay, let's see. So here
Oh
it,
wait, mom's calling me. Sorry, just a second.
all right, all right.
Hello.
Okay. So phosphorus is +5 here and +3 here. Okay. So what can you see? Is phosphorus accepting electrons or donating electrons?
I'm donating.
No, it's accepting electrons.
Oh, sorry, yeah.
It was +5 first, and then its oxidation number has reduced, right? And how can oxidation number get reduced? By accepting electrons. Okay. The equation would be something like this: P5 plus 2E minus, resulting in P3 plus. Okay. So it is half reduction. Okay. Reduction is gaining electrons. Okay. So it will be half reduction. Half reduction. All right. And then Cl5 is -5 here. Okay. And then it is -3 here. Okay. -3 here. So it would be something like Cl minus. So if I yes, Cl minus, oh sorry, what am I saying? Okay, so it is -1 here and -1 here as well. So where would the oxidation occur, right? So this is -1, this is -1, but see, this is 0, right?
Yeah.
So that means here we would see a half oxidation. Oxidation means by donating electrons. Okay, so let's see. Minus minus, so we will get it will be just 2Cl. Okay, or Cl2, you could write it either way. So these would be our two reactions, one half reduction and half oxidation reaction. Okay, understand?
Yep.
Okay, good. So see, I mean, you cannot just get convinced, okay, I have gotten one correct, then I should be able to do all of it. I mean, uh, it needs a huge amount of practice, you know. Okay, done. Taking notes.
Yes.
Okay, good. Okay. Do you know what electrolysis is?
It's, it is. Yeah. No idea.
I mean, to give you a rough idea,
Deionizing.
yeah, kind of like that. To give you a rough idea, say for instance, we will provide electricity to divide the what can I say, the elements of a particular compound, say for instance. Okay, so like it was made with some cations or anions maybe, or like say it had some uh, say for instance positive ions crystals and negative ions crystals, something like that. It would be like decomposed or divided into two parts like that. Okay, electrolysis. When we will study the chapter 8 of this book, and I don't know if it's there in your book, so we will study that in details, electrolysis, and then how can we make a electrolytic cells. And what is the application like in today's world? We can even like make like hydrogen fuel cell cards using the electrolytic cell. We can make batteries, something like that. So we will discuss it in detail in the next chapter, inshallah. All right, and I hope you will be able to like solve the uh, oxidation reduction reaction for this. But I will be real quick to solve this. +1 -2, and this is 0 and 0. Okay, so as you can see here, you can see that electron has been accepted. That means it is half reduction, and here electron has been donated. That is why it is half oxidation. Okay, all right. Okay, the substitution or displacement reaction, as I say to you that there is a particular activity series among the elements. Okay, so the element which is above in the activity series can easily replace or substitute the other elements which are in the bottom portion of the activity series, but the I mean elements which are in the bottom portion cannot replace or substitute the elements which are in the upper side. Okay. So for instance, if I give you an example, say copper sulfate plus zinc. Okay, now zinc is ahead of copper in the activity series. That is why we will get zinc sulfate plus copper. Okay, but whenever you are trying to, this occurs. Okay, but if you are trying to make a reaction something like this, um, say for instance zinc sulfate plus silver, this reaction won't happen. Okay, because silver is way down in the activity series, and that is why silver does not have the capability to replace zinc here. Okay, so this is the like easiest explanation of activity series, how activity series occurs. Okay, activity series example, you could write it like that. Okay, and I think as we are discussing about it a lot of times, let us just write it down as of now. Okay, so let's find it out and write it down by ourselves. Active, because you need to memorize. It has been a long time, I guess. Okay. This one, okay. So I guess just I mean take notes of this, okay? And you could write
Okay.
down the please stop calling me a zebra. Instead, try learning how copper saves gold. You could write something like that as well, okay? All right. Let me erase if you have taken notes of this. Have you taken notes? Yes.
Yes.
Okay, good. Okay, so be real quick and take note of this as well. Okay. I would have given you this homework, but whenever I give you homework, you tell me the next that you didn't get time. So it's better if you quickly take note of this here.
Okay. Done.
That was fast. I mean, how can it be done so fast? Like you have taken notes of all of it.
I can write fast with just that. I didn't do the other column, I just did the first one.
Please stop calling me a careless zebra. Instead, try learning how copper saves gold. This one.
Yes.
Okay, good. So then fill it up in the, I mean, would you be able to fill up the next column by yourself? Okay, at least take a screenshot if you find any
Okay.
division. All right. Done.
Yes.
I used to remember it with some, I mean, what can I say, mnemonic codes as well, but that won't work for you as I am a native Bengali speaker. Okay,
That's true.
right. So it was something like this. I can share it with you. So it's something like কে না কে ম্যাকগাইভার এলো যেন ফিরে পাবে হাই কসি পিটাবে আমায়. It's something like, if I translate it, it will be something like, who is this guy MacGyver who came here and thought about everyone would give him attention, and then some person named Kosi would beat me. Okay, so this is how it translates into English. I mean, these doesn't make any sense. Okay, but it's really helpful to remember. All right. So as you can see, zinc is able to replace hydrogen. That is why we're getting zinc sulfur. Okay. So this is how substitution or displacement reaction works, because a particular element is getting substituted or displaced. Now combustion, as you can, I mean, understand by the term, something would be combusted with the use of oxygen. Okay, all right. So the process in which any compound or element is burnt in presence of atmospheric oxygen and converts to oxides of its elements is called combustion reaction. You don't have to remember the definition. You can write it by your own. Usually heat is evolved in combustion reaction. We would study about like heat evolving reactions and heat conserving reactions again, and we will do maths as well regarding that. This process also involves electron exchange. For example, natural gas or methane reacts with oxygen of air and produces carbon dioxide and water. Okay. So did I tell you the like basic reaction of, I mean, chemical reaction for combustion reactions like
Um,
CXHY, and this is XCO2 plus Y by 2 H2O, and let me remember what was 2O2, just a second. I think X plus Y, or yes, X plus Y by 4 O2. So write it down. It's a basic skeletal equation, actually, basic skeletal reaction for any combustion reaction. For any combustion reaction, okay. Obviously, you have to burn hydrocarbons. That is, like if you say that, I want to burn, like, so for instance, iron. Obviously, that won't help this equation. But if you are burning any hydrocarbon means any compound which is made with only carbon and hydrogen. Okay. If you're burning something only made with carbon and hydrogen, then this is the basic combustion reaction. Okay, I will write it in bracket for hydrocarbons. Okay, for hydrocarbons. This is very important for your future because you deeply study about hydrocarbons in the future. You would study organic chemistry, and 99% of the compounds of organic chemistry are only made with carbon and hydrogen. Okay, there you would see different parts of our, hydrocarbons like alkane, alkene, alkyne, alcohol, aldehyde, and fatty acids. These are the 6 types of compounds you would find in organic chemistry. And organic chemistry is the most difficult thing, in my view, in chemistry. This is way too hard. Okay. And you just keep on, I mean, you think these things, memorizing these things are difficult, right? But if you just, I mean, stop reading organic chemistry for 15 days, I guarantee you that you will forget something. Okay. This is how vast it is. There are like tons and tons of things there. It's very difficult. Okay. Organic chemistry is very difficult. I mean, scaring you. I'm just saying that you have to be very careful from the get-go to be good at organic chemistry. Okay. And yes, you would find interest in it. Like there are like, what can I say, hundreds and hundreds of reactions involving with each other, but it's difficult. It's interesting, but it's difficult. And you have to give time to it. Okay. All right. And not only reactions, I mean, whenever you would write a reaction here, every reaction you have to remember what is the temperature, what is the catalyst you need to use. Okay. So, I mean, very, very difficult. Okay. That is the highest level of chemistry in my view. All right. Okay. Not to be afraid. We will study, inshallah. And you haven't sent me the book yet. Okay. So,
What book?
you said that you would make a digital version of your new textbooks, like the 5 or 6.
Yeah, just the activation codes aren't working properly, so I'm just the teacher's just giving me a new code so I can just
Okay.
put on the internet.
All right, so take it again and then let me know. All right, so now see these sorts of reactions where I mean you could see that there is no free element, right? There is no free element. Okay. So now you won't get any zero, a free zero, right? Which makes makes it easier to understand. So now, which portion would be involved in half reduction, and which portion would be involved in half oxidation? It becomes difficult sometimes. Now, why am I saying that? See, you would get oxidation number for all of it. Say this is -4, and this is +1, and this is 0. Okay, so we've got 1 0 actually. Now this is -2, and this is +4. Just a second, let me see. Methane is -2 +4. It cannot be just like okay, let me think, +1 and -2. Okay, so as you can see, there is no change in the oxidation number of hydrogen, right? Is it correct? Do you see any change in the oxidation number of hydrogen?
No,
It was
no.
+1 all the time. Okay. Okay, and in case of this oxygen, it was 0 and it has turned to -2. Okay, in both the cases. So the oxidation number of oxygen has changed to -2. All right, but here's the thing. We had 4 oxygens at the very beginning. Okay, and we have had 2 and 2, 4. Okay, so 4 oxygens as well. Okay, so let's see how this equation will work. So 4 oxygens, and each of them will accept 2 electrons. So all in all, how many electrons would be accepted? Tell me.
8. No. What was the question?
I was saying that each and every oxygen would accept 2 electron apiece. So how many electrons would be
Yeah.
accepted in total by 4 oxygens?
4, 8.
8. Yes, you are correct. 8
Oh, I
oxygens.
was correct. Yo, I was just guessing.
All right. Okay,
That
see.
never happened.
So, okay, let us just say in general sense, say you could do it as well. Say for instance, forget about balancing. Okay. So see, oxygen was 0 and it has to turn to oxygen 2 minus. Okay. So how many electrons will be accepted in this case? That is
2.
easy. 2, right? Okay. Now, how many oxygens do we have in the left side? 4. And how many on the right side? Of O2
4.
minus 4. So now let's just balance it. Okay. So multiply it with 4. Okay. If you feel this is easier for you, we can do that as well. Okay. First of all, write down the oxidation or half oxidation reaction, and then I mean what can I say? Balance it. Okay, this is not oxidation, however, this half reduction. And then carbon would accept eight, donate 8 electrons to become like this. So carbon 4 minus 80 minus, it becomes carbon 4 plus. Okay, this is a very strange, I mean, reaction, if you would ask me. Okay, I didn't get it particularly at my level. I'm stunned. I mean, carbon is changing from -4 to +4, right? That is very interesting. Very interesting. I hope I'm correct. Let me just check it. Okay. Methane combustion. Yes. Okay. All right. Okay. All right. So they're saying carbon undergoes a formal 8 electron oxidation. Oh my gosh. 8 electron oxidation. Can you just imagine that? 8 electron oxidation. This is ridiculous. Okay, so we're correct then. So there's no problem there. All right. Okay. So this one was the most difficult, and the other like oxidation reduction reactions are very easy. Okay, so these are just like getting involved with oxygen. So in the left side you will get just zeros, and in the right side you will get 1 plus and 1 minus. Okay, all the same for sulfur dioxide as well, 1 plus and 1 minus. Okay, so you can practice them. Okay, I hope you are understanding the things that I'm saying.
Yep.
Good. Okay, so enough talking about redox reactions, and we will practice them later as well. But let us study about non-redox reactions as well, right? Because not all the reactions in the world would involve like exchange of electrons, right? So there are two particular non-redox reactions at our level, at least. First one is neutralization reaction. What is the neutralization reaction? I told you previously as well. One acid and a base would react with each other to form neutralized compounds. What are the neutralized compounds? One is salt and another one is water. And another one is precipitation reaction. Okay. So we would study about a neutralization reaction. Neutralization. Okay. And the basic form of it is like acid plus base forms what is it, salt plus water.
Yes.
And then we also have precipitation reaction. And in this case you would see like, okay, we'll see it. Okay, so one of the compounds would get precipitated in the product, okay, or in the right side. One of it will be precipitated. Okay, you could write precipitation with this sign or maybe solid sign. So let's see. And why aren't there any exchange of electrons? We will see that too. The neutralization reaction, an acid and a base react with each other and neutralize into salt and water in some reactions, which are known as neutralization reactions. They are also known as acid-base reactions. Sodium hydroxide and hydrochloric acid, for example, neutralize each other and convert to NaCl, salt and water. Okay. Let us see or examine the oxidation number. So hydrogen +1, chlorine -1, sodium +1, hydroxyl -1. In the right side, sodium +1, chloride -1, and hydrogen +1, and hydroxyl, which we can see, will be -1 as well. So see, there aren't any change of oxidation numbers. What was our prime condition for a redox reaction? there has to be change in oxidation numbers, which we cannot see. So that means there hasn't been any transformation or transfer of electrons. Okay. So which means that all we can see the ions. So what will we call the all of these ions? Like what is H plus, Cl minus, Na plus, OH minus? What do we call these ions?
Uh, what do you mean by ions?
These are the ions. We have a specific name for those ions which do not exchange electrons in the whole reaction or the whole equation.
It's like observers or something. They were spectator ions.
Ions. Okay. So in these non-redox reactions, you will see that all of the ions are spectator ions. Okay. So that is why this is a non-redox reaction. All right. So there is no change in the oxidation numbers. That means there is um, no change in or exchange in electrons. That means they are all spectator ions. That is why they are neutralization reactions. So if your questions are asked that why is neutralization reaction called non-redox reaction, can you explain it? And don't just say that
Yes.
neutralization reaction is where acid and base reacts and then salt and water is formed. So that is not the whole explanation. That is that would be the definition of neutralization reaction. Okay. All right. So let me give you another link. Just a second.